Yes, sir.
Yes, sir.
Okay. So officially we are starting for the unit 2. So in unit 1 we have seen about the data pre-processing and later on the data processing. It is related to converting your data to the information or to the knowledge. So we require to do certain kind of the pre-processing and processing on that particular data. Now we learn the concepts of the data mining, where it's not like a simple SQL statement where we are going to retrieve the straightforward data. We have to find out a different logic from that particular data. Like if you are having a certain class and if you want to calculate how many students have secured marks greater than 60%. In that particular case, you can write down a very straightforward query, but you want to find out students from the scholar batch, student from the remedial batch, etc. In that particular case, you have to set certain kinds of the rules for the scholar batch, certain kinds of the rules for the remedial batch, and based on that particular rule you have to write down a complex query. So this particular thing is to be done in the case of the data mining, and you are going to retrieve the respective data. Later on, we found that the concept about the Hadoop programming, there are two operations, map and reduce, and we require, because we are having a big data. Now, what is the meaning of big data? You are collecting the data from the different types of the resources, and therefore the quantity of that particular data is big. Not only quantity, but a data is coming from the heterogeneous platform. Therefore, data is presented in a different form. That's why it creates a problem. And how you are going to make, or how you are going to find out a query from a certain heterogeneous kind of data. So you need to do certain kind of additional thing, and that is converting your data into a respective data frame, so that you want to make your data into an organized format. And once it is organized, then you can find out a respective solution. Like suppose if I have collected a data from 4 colleges, I have to create a new data set which will be retrieving data from all those particular 4 colleges, and later on I can form a solution. But all the time it is not feasible. So what we do, we try to find out different techniques for that kind of data processing. One of the best technique is the Hadoop, where you are having two programs. One is called as the map, and the second one is called as the reduce. We call it as a function. So the map is going to do a mapping according to the respective classes, or according to the respective your features, and the reduce is there, which is used to just reduce your program or reduce your data according to those particular classes. So the final action will be taken by the reduce. Now, the main problem of the Hadoop is you are supposed to retrieve the data or the retrieve the element from the hard disk or the disk, so that you require certain kind of additional time, so that you want to load your data into the memory, and later on it will start the executing. Means whatever that you are executing, that is loaded to the disk, and then it is then it is acquired back, and then once you are getting that particular back, and then you are going to get the execution. So this is a quite simple but complex structure of, if you say the complex which is related to the execution. It is quite simple because you are having a two operations, and you know what you are supposed to do in the mapping and what you are supposed to do in the reduce. So it gives you a very stable output in this particular case. But suppose if you want to have a speedy execution, if you want to execute your program quite rapidly, in that particular case we can execute our statements into the memory. So everything will be, the data will be uploaded from the memory, it will get executed, and then you are going to get the result. Definitely your statements are also going to get executed in the memory, and therefore we do not require any kind of additional cycle for fetching that particular data. But again, we are having a difference. In the case of Hadoop, we have a HDFS, Hadoop file system, and in the case of Spark, we are having the RDD. So we are in the Spark, we are acquiring all those particular instructions, all those particular data from the memory, so that it allows you to execute your data into a speedy way. But instead of HDFS, we are using the RDD, that is a resilient distributed data set. Now, let us understand what is the meaning of resilient distributed data set. Before that, we will understand the unit 2. Now unit 1 was totally basic things related to the Spark, and now we are going to learn about the ecosystems in the case of the unit 2. So unit 2 is entirely practical oriented and it is a very short unit. So initially we will understand what is the meaning of RDD and what is the meaning of logical execution plan. And second, we will understand different types of the ecosystem. Now we have defined different types of the ecosystem like Spark Streaming, Spark ML, or we can call it as a Spark MLib. Then Spark SQL is also there. Spark R is also there. So there are several things, and accordingly we are going to just take the help of those particular ecosystem to retrieve the respective output. Now all those particular ecosystems are going to work to give you a certain output. For example, if you want to process a stream-wise data, you're having the Spark streaming. If you want to predict a data, you're having the Spark MLib. So basically, you are going to take the help of all those particular ecosystem as per your requirement. So we will start one by one. So initially, let us understand what is the meaning of the RDD. The full form of RDD is a resilient distributed data set. So whenever whatever data that you are uploading will be distributed across the several machines, and you are not aware that about where that particular data is actually loaded. So you can load that particular data. I will just show you in one diagram. So here in this particular way, you are going to load your data. So this is your file. And these particular files will be distributed across the several machines. Suppose there are 4 machines. So depending on the size, now you cannot say that this particular file is equally distributed across these particular 4 machines. No, we don't have any kind of equal distribution. Now the distribution is totally dependent on the size of the server or a particular algorithm that you are using. So this particular thing will go accordingly. So here you are going to distribute your respective data, and there is one cluster manager. Okay, these are your nodes, and these particular nodes will be managed by, this is a particular cluster. You are going to form a particular cluster for this particular data, and there is a one cluster manager. So whenever you are firing a particular query, the cluster manager is responsible for retrieving that particular data. Or whenever, whatever that you are doing, means whether you are uploading your data or you are just getting the information as per your requirement. So all the part will be done by your respective cluster manager. So in other words, the
So
cluster
your
manager,
data will be.
yes, sorry. Sorry, can you repeat your question?
So your data will be loaded particularly in Hadoop or any other data storing platform.
No, now we are using the Spark. We are considering the Spark. So it will be loaded with respect to the Spark. Hadoop is not a server. Hadoop is the tool which processes your data and which uploads the data. Similarly, the Spark is also there, which is going to convert your data into the RDD. That is a resilient distributed data set, small chunks of the data set, and that will be distributed across the server. And we don't, as it is a distributed, we don't know where particular data is uploaded because of the property of the distributed system. And there is one cluster manager who is going to take care of this. So whenever you are putting certain kind of the query, that will be received by the cluster manager, and the cluster manager is responsible to find out the respective answer. So user will be connected to the cluster manager, and your cluster manager will be connected to a different types of the resources. So accordingly, if you want to fire a query, you will fire a query to the cluster manager, and cluster manager will collect the data. Now data might be collected from 4 machines, but you will feel like that you are getting a data from a single machine. So it is managed according to the speed and the fault tolerance. Means, for example, suppose if certain node gets failed, still you are able to recover that particular data from the other node, because also you are going to keep some copies on other servers also. So that particular part will be taken care by the cluster manager and your distributed system. So the data is divided and that will be loaded to a particular server. The server, a normal server that you are going to use for the processing. It can be a cloud, It can be your local host. It can be anything. But the Spark and the Hadoop is the tool which processes your data and gives you a way for respective processing. Okay,
Okay, sir.
fine. So basically that particular data is distributed, and now you are able to use a cluster manager to find out that particular data. Now let us understand what is the concept of the RDD lineage. We are calling it as a logical execution plan. So before going into the definition, let us understand what are different operations that are associated with the RDD. So the first operation is called as a transformation. So the first operation is called as a transformation, whereas second operation is called as the action. So in Hadoop, we are having two operations. One is called as the map, second is called as a reduce. Similarly, for a Spark, we are having two operations. One is called as the transformation and the second one is called as the action. Now don't try to relate map reduce with this particular thing. Means it is not like that the map is associated with the transformation and the reduce is associated with the action. The transformation is responsible to create a new RDD. So whenever you want to create a new RDD, a transformation will be in an active role. And whenever you want to extract the information, extract the data from that particular respective RDD, that can be anything. Means you want to extract, means it's not like that you want to extract the normal data. You can find out a summary, statistics, whatever it will be. So that particular part will be done by the action. So transformation is having certain functions like map. One is the map, second is the filter, and third is the flat map that we have taken into the last lecture. And the action is having methods like count, then collect, etc. Okay, so basically you can see what is the meaning of the count. It is going to count the element. Collect, it is going to display all the element. What about transformation? If you want to create the RDD, you can use a map or a flat map. Flat map and filter can be used for a selections. So if you want to create the RDD for a particular selection according to a particular selection, then you can make the use of a filter or the flat map. Means for example, if I'm having a MSc student data, and suppose if I want to make the changes in all students, okay, means for example, if I want to add or if I want to change the ID of all students, what I will do, I will use a map so that this will be reflected to the entire data set and it will create a new RDD. Similarly, if I want to do this particular thing for a particular group, like suppose if I want to change the ID of a data science student, in that particular case, I will be using filter or a flat map. Okay, so in the case of the filter or the flat map, I have to give a certain kind of the condition. And according to that particular condition, our data will be modified. Okay, so every time, what is the fundamental thing of the Spark? You have to write once and use many times. Means for example, if you want to make any changes, you have to create a new RDD. Okay, if you want to make any changes, you have to create a new RDD. Now, if you want to keep previous RDD or if you want to discard that particular RDD, that is your choice. Or that particular thing should be written into the logic. So the main part, if you want to make the changes, it will create a new RDD. For example, suppose if I'm having a number from 1 to 100, and suppose if I want to make the change in the for the 52 number. So what I will do, I will be very selective for the 52 and I will make the changes over here, and now it will create a new RDD. So all numbers from 1 to 100 will be same except 52 because I have modified 52. So each time we have to create a new RDD. So how the scene is going to become? So this is your original RDD. Suppose it is having a number from 1 to 100. I feel that I should split this particular RDD. So it can be splitted accordingly. Like from in the first part, I will be having 1 to 40 numbers. In the second part, I will be having 41 to 60 numbers. And in the last part, I will be having 61 to 100 numbers. So this is the second hierarchy. This is the second hierarchy. This is the first hierarchy. So I will just give the new names, some name to those particular RDD. It will be say R. It will be R0. It will be R1. It will be R2. It will be R3, and so on. Okay. Don't feel that I have to just divide the data. I can make the union also. Means somewhere, if I feel I should join R1 and R2, that is also allowed. So that at the third hierarchy, I'm again making the new RDD by combining R1 and R2. So here I'm combining the R1 and R2 so that R1 and R2 will be having a numbers from 1 to 60, and I will name this particular RDD as R3. Sorry, R4, because I'm having R3 over there. I'm not going to make the changes in R3 because, or I'm not going to create the new RDD from R3 because I don't want to make any changes. What is the rule? If I want to make the changes, then only I have to create a new RDD. In this particular case, first I have to divide this particular data set into 3 groups. You can see it's not divided equally. It depends on my logic. So I have created 3 different RDDs, and then one more RDD that is called as the R4. So the R4 is evolved from R1 and R2, so that you can get that particular respective data over here. Okay, so here you can find out a different kinds of the logical relation between R0, then R1 and R2 and R3. Okay, and then from R1 and R2 you have evolved R4. So R0 is going to give birth to the R1, R2, R3, and R1, R2 is going to give birth to the R4. So this kind of relation or this kind of connection, whatever the hierarchy that you have drawn over here, is known as a lineage. So that is called as a logical execution plan. So accordingly, we are having a recent copy as a child, that is R3 and R4. And these are the old copies. If you want to keep those particular copies, you can keep, or you can simply discard. Okay, so accordingly, you are going to make these particular things. So this particular diagram is known as a RDD lineage. Now let us see the definition. So the RDD lineage is a graph of all parent RDDs of an RDD. So whatever the evolution that you have derived, it is represented in a diagrammatic manner. Okay, so here you can see this particular diagram is drawn. So here you can see one more additional thing. The R1 is taken from R0, some part of is taken from the R00, and some part is taken from the R01. So it's not like that. A particular RDD can be child of a single parent. It can be a child of a multiple parent also. So for R12, there are 2 parents. One is R00 and R01, because they are taking a data from that particular element or that particular data. And similarly, both are going to give birth to the R20. Again, R20 is also having, it's a union. Okay, this is also on the example of the union, but here it's not, it's a partial union, because only some part of the data and from the R00 and some part of the data from R01 is united in R12. The R20 is not such case, because all the data is united into the R20. So this particular part is going to consider your plan. Now next is related to the logical execution plan. So all this particular diagram will be related to a logical execution plan, and it shows that how the RDD is evolved or how the RDD is developed. So it defines, you can call it as a footprints of your data set. Okay, now moreover, you are doing all those particular things by the means of the transformation. So for this, you are going to use a transformation, not an action. So many times, whenever you are doing certain kind of the transformation, you may require to store a state of that particular object. For example, let us have a condition, or let us have one example. Suppose there are two data set. Suppose there are two data set. One is a sport data set. The sport is having two sections. One is called as a theory, and the second one is called as a practical. And then there is an academic section. The academic section is having a 7 component. 3 theory or 4 theory and 3 practicals. This is related to a certain kind of the college, and you have to display a result by combining the sport record and the academic record. So that will be displayed as a result. Okay, fine. Now, every time what will happen, suppose if there is a certain kind of roll number, let me say it is a roll number 1. So his sport theory and the sport practical will be added, that will be displayed as a X. And then all academics will be added, that will be displayed as a Y. And X plus Y will produce a result. So this is a normal system. This is a normal result processing system. But suppose due to some reason, all students from roll number 1 to 100 have secured 20 marks in the theory, or they are given or they are awarded due to some problem. The sport examination is not conducted, and all students have given 20 marks for the theory and the 20 marks for the practical. In this particular case, the value of X is fixed, that is equal to 40. So whatever marks that you are getting as a Y, is these particular examinations are taken, so that they are going to vary according to their marks. So Y is going to change. That we don't have any doubt in this particular part. But if the sport examination is not taken, and for a theory, the college is going to award 20 marks, and for practical also the college is going to award 20 marks for all students. In this particular case, the X will be having a fixed value, that is 40. So you can store this particular value somewhere. Instead of calculating for 100 students, if you instead of calculating 100 students, this addition for the 100 student, you can store this particular value 40 somewhere, and you can use it. So this particular part is known as a RDD persistence, and this is one of the method of the optimization. So if we know the result is fixed or the result is stationary, in this particular case, we are not going to evaluate the states. So instead of evaluation, we are using that particular value, and for future use, we are going to store that particular respective value. So this particular method is called as the RDD persistence, and it is used as a optimization method. Moreover, if you want to store the intermediate states, then only you can use the RDD persistence, so that intermediate states value will be stored, and at that particular time, you need not to execute this particular. Means, for example, suppose if 4 theory marks are arrived, if all 4 first theory marks are arrived, but the practical marks are not ready. In that particular case, as you have calculated all the theory marks, let me call it as a Y1. So the Y1 will be stored somewhere. And then once your practical marks are ready, that will be added to that particular practical mark. So what will happen? Initially, for calculating Y1, you have executed the addition of 4 subjects. As the quote marks are going to be defined. So by the means of, if you are having a fixed value, if the values are not getting changed, you can just store those particular values, and this concept is known as a RDD persistence. So there are two methods. You can use a memory. If you are using only memory, you are having cache method. And if you are using a memory along with a server memory or a disk, you have to use a persist method. So for RDD persistence, you have to use a cache or a persist. If you are using cache and if your system is rebooting, in that particular case, a value will be cleared. Not all the time, but if you are using a memory of a server, then you need to reboot your server to clear that particular value. Otherwise, these particular values will get updated accordingly. For a persist, you are going to store with a different levels that we will see further. They are like a memory only, disk only, the memory and disk only, then memory of a server, etc. So accordingly, the levels will be decided where you want to store that particular value. And for that purpose, we are going to use a persist. Okay, so now we have explained the need of the persistence, and the benefits are three. It is going to save your time, therefore it is a time efficient. It is also going to save your CPU cycle, therefore it is a cost efficient, and it is also giving you a less amount of time for the execution, or it is allowing you to execute your particular method or a particular task in a less time, therefore it is a lessened execution time. So different storage levels for the persisted RDDs are defined. That will be done with the persist. One is the memory only. So it will store into the memory. The name itself is going to suggest the memory and disk. So it stores some excess partition of the disk and it will store the value over there. Memory only server, so that a particular value will be stored on that particular server. Memory and disk server. Now here you are going to use a server memory, and here you are going to use a memory of the local host or the server and disk of the server. So here only memory component will be used, and here you are going to use a memory as well as server. Here disk only, in the case of disk only, you are going to store on a disk of the local host machine. So there are 5 levels, and according to these particular 5 levels, they are going to, it's going to be executed over here. Next is unpersisting RDD. So whatever that you have stored, you have to just clear that particular thing, and accordingly it can be done with the help of unpersist. So it will clear all the data. So mostly it is going to use the LRU fashion. The LRU means least recently used. So it ensures that a least frequently used data will be cleared. So it's not going to clear the entire thing. It's going to clear the one by one. And here we are going to use the formula for the LRU. Means a value which is not recently used, not frequently used, not recently, frequently used, that will be removed. Accordingly, this particular thing will be over here. The next part is related to the Spark streaming. Now let us understand the definition of the streaming. A streaming means is an example of a continuous data. So possibly a continuous, if the term is coming as a continuous, it is online. A data which is coming in an online manner, which needs to be processed during a real time, is called as a stream. And to handle a data, we have a concept of the Spark streaming. So what is the meaning of the Spark streaming? So the Spark streaming is a scalable, fault-tolerant streaming processing system that natively supports both batch and a streaming workload. So here they are going to support both batch as well as the streaming. Now, if you go with a batch processing system, you have to go to the offline. Even for streaming or processing those particular stream, you have to go for the offline. If a data has to be processed, if the data itself is having certain kinds of the breakpoint, in that particular case, you can go for the batches. Like if the cricket match is going on, there is a certain break between 2 overs. So you can process a 1 over data, then the second over data, that can be processed. But if the data is fully continuous, we don't have any kind of the break. So you have to break that particular data into a shorter batches or into a smaller batches. This is known as a discretized stream, or in other words, we are calling it as a D stream. So we know we are going to collect the data from different types of the online resources like Kafka, Flume, Amazon Kinesis, various sources. Those particular data will be converted into the small batches. We are calling it as a discretized stream, and then those particular data will be processed with a different types of the Spark ecosystems or a Spark component like MLeap for the machine learning concept, the for Spark SQL for finding out a respective query, etc. So this is related to the Spark streaming. So four major aspects: the fast recovery from the failures and the stragglers. Second, better load balancing. Third, combining of the streaming data with a static data set, so you can generate the layers that we are able to see in a live match. Native integration with the advanced processing libraries, SQL, machine learning, graph processing. So for this, let us have the example of the cricket match. Uh, I think whenever first time when Geo Cinema was telecasting the IPL, the first match was not able to see it on by the many people. It is because of the load balancing. Then they recovered, then they developed their software accordingly, and then now we are able to see those particular matches. Even if you are looking at the cricket matches, if you are watching the cricket matches, you are able to see different types of the statistics, different types of the predictions, like the scores that will be predicted or the win predictor. For that, we need to go with the Apache Spark components like a machine learning. Just a minute. Sorry for the interruption. So basically, these are four aspects for the Spark streaming. I repeat, the faster recovery and for the from the failures and the stragglers, better load balancing and the resource uses, combining of the streaming data with the static data set and the interactive queries, and the native integration with the advanced processing libraries like different types of the SQL, machine learning, and the graph processing. So these particular parts will be considered as a four major aspects. Now this is the diagram for the Spark stream processing. One is called as the, you can see the different input sources like Kafka, MongoDB, that from there you are receiving that your data. The different types of the Spark component like Spark SQL, machine MLeap. So that is going to process your streaming data. And then the last part, again you are going to get that particular data to the original source. So the same sources are going to receive the data. Okay, so that is main thing, because the one you have to receive that particular data, not it get published as a dashboard, not only to publish it as a dashboard. Therefore you have to process that particular data in a real time, and that is a big challenging task over here. So different types of the Spark components like Spark Streaming, Spark SQL, GraphX, machine learning libraries are going to interact with them. This is a data frame, and a core one which is going to perform. Now, what is the meaning of the core? It helps you to create the RDD, that is a resilient distributed data set, so that your system becomes available or the essential for the IO functionalities. That means you are able to receive a new number of resources, and also you are able to complete or you are able to work with the old resources over there. So mostly that particular part will be done by the transformation and the action. Second is a Spark SQL. It is having a limited functionality because mainly you require a structured and the semi-structured information if you want to go through the Spark SQL. It is having all the properties of the SQL. Therefore, we are calling it as a powerful, interactive, and many things over there. It is very useful for the streaming and the historical data, etc. But the main part is whatever the data that you want to take as an input will be in a particular structured or the semi-structured information. The streaming, that part we have done just now. The graphics, now this particular graphics is just like the API for the graph or the graph parallel execution. So it gives you a network visualization, any other kind of visualization like clustering, classification, traversal, searching, pathfinding, that will be done over here. The statistical operations are supported by the SparkR. So the SparkR provides a distributed data frame implementation which supports the statistical operations like selection, filtering, aggregation on the large data set. Then, if you want to implement a machine learning algorithms, you are having a MLIP. So the MLIP is consisting different types of the algorithms, popular algorithms, and the utilities which are used for the regression, classification, clustering, pattern mining, and the collaborative mining. So these particular algorithms are decided on the requirement. Means if you want to classify the data and if you know the classes, in that particular case, you will go for the classification. If you don't know the classes, it will go for the clustering. If you want to retrieve the future data, you will go for the prediction. If you want to find out, convert the discretized data into the continuous format, you will go for the regression. If a data is having certain kind of the sequence, then you will go for the pattern mining or a collaborative filtering. So accordingly, you are going to follow those particular algorithms as per your requirement. Whatever the requirement is there, accordingly, you are going to follow the respective algorithm. So these are enlisting of the MLIP tools, the algorithms, the featureization, pipelines, persistence, and the utility. Now, in the case of algorithm, we are having two concepts. One is called as a transformer, and the second one is called as the estimator. So, for example, what is the meaning? What we are going to do in the case of the machine learning, we are trying to relate the input with the output. So, for example, I'm having a sequence. Let me call it as a 1, 2, 3, 4, 5, 6, and I'm having the output sequence as 1, 4, 9, 16, 25, and 36. Okay. In machine learning, I want to find out a relation between X and Y, and that is done by the transformer. So as an output, I'm able to find out a learning model. I'm able to find out a respective learning model. So learning model is going to define how my input X is converted to the Y. And that particular formula will be the output of my learning model. So what I will do, I will divide these particular data sets into two parts. So let me say the 4 and 2. The first part will be called as the training, and the second part will be called as a testing. So training part is the example of the transformer, which is used to evaluate or which is used to find out a respective learning model, whereas the testing part is called as the estimator. where I will find out whatever I have evolved as a learning model, or whatever I found as a learning model is fitting to the particular environment or not, is accepted by the environment or not. So the accuracy will be calculated by the estimator. So what will happen now, if you are able to see closely, the y is a square of x. So I will define my function f of x is equal to x square. So this is my learning model. And what I will do, I will discard these particular two numbers. I will not use these two particular numbers. Instead of that, I will try to calculate my y dash, a new value, by using a learning model, so that I'm able to find out a respective, the accuracy of the model. So what is the square root of 5? It is a 25. The square of 6, 36. So I'm getting the value exactly as y. Therefore, I can say the accuracy is equal to 100%. So the estimator is going to give me the accuracy of my respective model. So you can see the transformer is the algorithm that transforms one data frame into another data frame. We know we have converted the data into the particular training and the testing, and it is exactly used for the features. Now the features means the properties. The properties by which you are converting your data from x to y. Like you are having a fruit. Why you are calling that particular fruit as the apple? It is because of the features of the apple. This particular part is known as a feature transformer, and the feature transformer is going to lead your respective learning model. The estimator is an algorithm which can be fit on a data frame to produce a particular transformer, so that it gives you, it allows you a learning model. It accepts the respective learning model by giving a certain method. The featureization is include what properties are acquired during the transformer phase, and which properties that you are going to verify during the estimator phase. Like for example, if you are having the apple, you can have a different properties like shape, color, taste, and size. Okay, suppose for these particular properties, these are the properties for a particular fruit. So this is known as a feature extractor. So I'm going to use these particular features. There are many features. If you go with that, there are many features, like smell is also there. But I'm not going to use a smell. So that will not be a part of my feature extractor. The feature extractor is one which is going to produce your actual features accordingly. So the feature extractor is going to play the important role to determine that particular object. Suppose if you are using a feature extractor serially, means first shape will be detected. If shape is coming positive, then color is detected. If color is positive, then test is detected. If test is positive, then size is detected. And if size is also positive, then it is an apple. But suppose if shape is detected positive, then color is detected as a positive, but I'm getting failed at test. It is negative. So what will happen? I'm not going for the size, because my model has denied the existence of the apple at the third stage. So here you are going to follow a one step after the another step, and that will be done by the pipelining. The next concept is the pipelines. So it chains a multiple transformer and estimator together to specify the ML workflow. So it constructs, evaluates, and the tune respective machine learning pipeline. We know the data frames that are user-friendly APIs than the RDD because they are well structured. So basically, whether you are using the machine learning applications, whether you are using the SQL application, both time you will be using this particular data frame, or you have to convert your data into the data frame and then you can make use of it. The persistence is done. Now the statistical functions, that is a Spark R. Basically, we use a random data generation. Many times we have to generate a data. So the data will be generated randomly, or it will be generated based on certain kind of the formula. So a random data generation is the most important statistical function that we need to use during the execution. Whatever data that you are having, you can create a summary or descriptive statistics of that particular data. So it may serve as a metadata in a particular case, and that is known as a summary and descriptive statistics. Next is the covariance and the correlation. We know the concept of the covariance. For example, if there are certain fixed things in a word, and they are having a property which is denoted as a straight line, and we have developed a model, and our property is coming like this. So whatever difference that you are getting is known as a covariance. So that we are able to find out how much system, or how these two particular two variables are going to change according to each other. So this particular thing, definitely we are getting this particular part as a part output of some value. So we have to check how this particular model has derived, and how those particular two variables are related to each other. Second part is called as a correlation. So you are going to combine a value with each other. You are going to combine two different sequence. That part is known as a cross correlation. And if you are combining a single sequence with itself, that is known as a autocorrelation. So these particular things are going, means you are having a standardized data, and you are just going to compare the performance of your respective data according to the values that you are going to get. The cross tabulation is also there, which is another statistical tool which is used to obtain the counts of a different pairs of a particular data. So again, this particular part will be used as a part of the feature extraction. And then the frequent items. So this is related to the pattern mining or a collaborative filtering, so that you are able to find out frequent items. Based on that, you are going to define your respective data sets, respective values of your system. For example, if you want to develop a software for a grocery system, this particular, you have to follow the pattern matching or the pattern mining, because the things will go according to some pattern, and you have to follow that particular pattern. Means, for example, during Diwali, you cannot keep the things which are related to the Christmas. And during Christmas, there are several common things also, but you have to make the arrangement of the things accordingly, so that these particular things are related to the event or the related to the goals. And the last part is the performance. So memory, speed, distribution, and the performance. The performance is related to the quality of the services, and the quality of the services is totally dependent on the data, that how well you are processing your data, how well you are going to perform the data pre-processing, and based on that you are able to generate the respective solutions accordingly. So these are for performance. Memory, you need to save the memory. Your application should be speedy. The distribution should be properly. Therefore, you have to make these particular things. These arrangements should be done during coding, so that you are able to find out your respective things properly. And the performance is there, that you should able to find out your respective data the appropriately over here. So this is related to the first chapter of your second unit, which is the RDD lineage and the Spark streaming. I think that is enough for today. So if you are having any kind of the queries, doubt in today's session, from today's session, you can ask.
Sir,
Any queries?
Hello. Sir, attendance.
Yes, first let's clear your queries. Once all is done, I will take a screenshot. Meanwhile, I'm taking the screenshot actually.